So this is the second question which we are going to discuss related to equivalent capacitance calculation. So here you can see this circuit which consists of these capacitors with their values which are connected in the given way, and we have to find out the equivalent capacitance across the terminals A and B. Okay, so I have already told you a tip related to calculation of equivalent capacitance or equivalent inductance or equivalent resistance is, first of all, looking at a circuit, you must first try to identify patterns of connection. Okay, try to identify patterns, whether a given number of capacitors, resistors or inductors are connected in series or parallel, in whichever way. So first of all, we have to find out the pattern in which they are connected. So if we look at these three capacitors, the 1 farad capacitor, the 2 farad capacitor and the 3 farad capacitor, if we look at these three capacitors, we can see that they are connected in parallel, with their one ends being connected at this point and the other end connected at this point. So the equivalent capacitance of these three capacitors, okay, involving these three capacitors, will be simply the addition, means 3 plus 2 plus 1 farad, which is equal to 6 farad. Sorry. Now, uh, for a beginner student, most of the beginner students, they make a mistake, is that by they calculate 1 by C equivalent is equal to 1 by 3 plus 1 by 2 plus 1 by 1, means they do that because they think that these three capacitors are connected in parallel, so the equivalent capacitance will be calculated in the same way we calculate equivalent inductance and equivalent resistance. But this is wrong. This is right, because in capacitance it is the opposite to that of resistance and inductance. When a number of capacitors are connected in parallel, the total capacitance, the total equivalent capacitance will simply be the sum of the individual capacitances. So don't do this mistake. Okay, with practice it will come. Okay, no need to worry about that. All you need to do is practice more and more problems. Okay, so the equivalent capacitance of these three combination, 1 farad, 2 farad and 3 farad, is 6 farad. We calculate. So now let us redraw the circuit. Okay, we'll redraw it here. So this is A, this is 6 farad which we calculated. Then we have this 12 farad and this is B, and there is a 10 farad capacitor. 10 farad. Now you can see in this circuit, again we have to identify pattern. These two capacitors, the 6 farad which we calculated the equivalent capacitance of these three capacitors, and this 12 farad capacitor, they are connected in series. So the equivalent capacitance of this combination, okay, this combination of 6 farad and 12 farad will be, here we will use the formula of reciprocal. 1 by C equivalent is equal to 1 by 6 plus 1 by 12, and directly we can also calculate it as 12 into 6 by 12 plus 6. We will get the same result if we do it. Okay, so we will get around 72 by 18, which is equal to 4 farad. Okay, it is the equivalent capacitance of this combination of 6 farad and 12 farad, which we calculated as 4 farad. Now again redrawing the circuit, it will be, let us just remove this part. Okay, it will be 4 farad A, B, and we have the 10 farad capacitor. So now this 10 farad and 4 farad capacitance, they are connected in parallel. Okay, so the total capacitance of this circuit combination, okay, which we have reduced it, we've reduced it until there are only two capacitors left. So the total capacitance will be simply the capacitance between A and B is equal to 10 plus 4 farad. Because they are connected in parallel, we'll simply add them, equal to 14 farad. Okay, the equivalent capacitance is 14 farad. So this result CAB is equal to 14 farad. So all you have to do is, first of all, looking at a circuit, you have to identify patterns of connection, whether uh, two capacitors or three capacitors or as many number of capacitors, in which way they are connected, whether they are connected in series, whether they are connected in parallel. Then find the equivalent capacitance of that combination, then again find out patterns of connection, then also keep on reducing and until you simplify the circuit in this way. So here what we did, we first identified the pattern of connection between these three capacitors, 1 farad, 2 farad, 3 farad. We reduced them in one capacitance. Then again the resultant capacitance and this 12 farad, they were in series. We found out the equivalent capacitance. Then it was connected in parallel with 10 farad and we subsequently found out the equivalent capacitance as 14 farad. Okay, so this is the second question where the equivalent capacitance was found out to be 14 farad. So let's take up some more questions.